Avogadro's law is found on page 2 of your packet, and Avogadro's law is the focus will just be the top 2 questions on the page, so it's just questions A and B. If you've noticed, what I've done is I've went ahead and I've carried over your formula for Avogadro's law, so V1 over N1 equals V2 over N2, and I've also brought over a unit conversion for volume, just as a reminder that every 1,000 milliliters is equal to 1 liter. So I've transferred those over to your page. So let's take a look at question A. Question A says, if 0.214 moles of argon gas occupies a volume of 652 milliliters at a particular temperature and pressure, what volume in liters would 0.375 moles of argon occupy under the same conditions? So I want to go ahead and take a moment and just remove some information from the question that's not necessary for us. And so it might actually just serve as a distraction being present in the question. So when it says at a particular temperature and pressure, it just means that it's hanging out at a certain temperature, there's a certain pressure for it. Clearly they've not given you those actual numbers, and so you don't need to know this information to solve the question, and it doesn't make a difference what those values are. They're not going to affect your calculation. So I went ahead and just removed it from the question. I want you to notice too that I also, while reading the question, I also went through and I underlined all my data so it'd be easier for me to label it. And so the 0.214 moles, that's clearly going to be represented by the variable N. I just don't know yet if it's N1 or N2. That amount of moles is at specifically 652 milliliters worth of volume. So this right here is going to be a V for volume. I'm searching for a different volume, and notice that they specifically told you that this volume is going to have to be in units of liters. So I know that I'm going to have to solve for a new V variable. What volume would now 0.375 moles of argon occupy under the same conditions? So again, this is going to be N for moles. So by the same conditions that they're referring to, they're basically just meaning whatever was happening with the 0.214 moles at 652 at a specific temperature and pressure, you've not changed anything else about the scenario. It's still the same setup. You're just now looking for the new volume that's going to exist when your moles change to 0.375 moles. Okay, let's label our variables as either 1 for before or 2 for after. So if 0.214 moles of argon occupies a volume of 652 milliliters, I know those two go together. If I'm asking for the volume that now 0.375 moles of argon is going to occupy under just the same conditions, that means I'm ultimately looking for the new volume that's going to exist. So this is my V2. So my V2 was existing at this particular amount of moles. And if my 0.214 moles went with the 652 milliliters, that was my original mole quantity and my original mole volume. My new mole volume was 0.375, and now I'm going to try to figure out what volume is that going to exist in, and I need to make sure that it's in units of liters, because my original volume is in units of milliliters. That's my V1. So let me go ahead and set up the formula so I can isolate for my variable. Remember, our Avogadro's law is V1 over N1, and that's going to always equal V2 over N2. I'm searching for V2. So since I'm searching for V2, I want to go ahead and get rid of N2, which is in the denominator. So I'm going to say times N2, and I want to say times N2 on both sides. So now notice what happens. N2 cancels out. And so my formula now is V2 equals N2 times V1 over N1. Before I plug everything in, I need to make sure my units are all the same so that they all cancel. So clearly my moles are just both in moles. I wasn't given grams. I don't need to convert to moles. I'm all set with N1 and N2. My V1 is in milliliters, but my V2 that I'm solving for has to be in liters. So I know I'm going to have to convert milliliters to liters once I plug in V1. So I'm going to go ahead and just put this into my problem. N2 is my first variable. So I'm going to say 0.375 moles. That's my N2. My V1 was 652 milliliters. I want to get out of milliliters and into liters, so I'm going to go ahead and set up my conversion factor that I brought over from my formula sheet. Every 1,000 milliliters equals 1 liter. I'm going to set it up so 1,000 milliliters is in my denominator, and those units cancel, and I'm left with 1 liter in the numerator. I'm now done with my numerator. I want to make sure that you're comfortable understanding how I got out of milliliters and into liters. So if you notice 652 milliliters, I have milliliters right here. I have milliliters over here. I'm going to be left with just liters. Going back to my formula, I had N2 times V1. Now I just need to fill in my denominator, which is N1. And so that's 0.214 moles. Okay, let's now let the calculator do this part of the work. So remember, you want to do your conversion first. So the first thing you'd want to do to clear your volume, so to clear this information out, you would want to go ahead and go to your calculator and do 652 divided by 1,000, because remember, 1 is in the numerator, 1,000 is in the denominator. So you're just doing 652 divided by 1,000. Whatever that answer is, you're going to now multiply that by 0.375 moles. So 652 divided by 1,000, get your answer. Take that answer and now multiply that by 0.375. Hopefully, once you've done that, you know that your calculator stares back at you with 0.2445. If you set it up correctly, that's your answer for the numerator. Your denominator is just 0.214, and you're not multiplying by anything. It's the only variable there. So that's going to just be divided by 0.214. Notice that the only unit remaining is liters, because let's go back into the formula. You have moles in the numerator, moles in the denominator. We already took care of seeing how our milliliters cancel. The only unit remaining is liters. And that's the unit you wanted because you're looking for the new volume that had to be given in units of liters. So what I'm going to ask that you do now is I'm going to ask that you nicely label for me your calculation answer on your page, and then go ahead and give me your sig fig answer, right, that includes the units. So give me your final answer. Just in case you need a moment to review sig figs, I'm going to go ahead and take time to do that right now. So looking back at my question, I'm going to use all the data that was provided for me. I have 0.214 moles. This only has 3 sig figs. I also have 652 milliliters and 0.375 moles. So 652 milliliters, this is also 3 significant figures. And 0.375 moles, that's also 3 significant figures. So when you give me your final answer down at the bottom, you're going to make sure that you're going to give your answer in 3 significant figures.